Hi, my name is Kelver Merlotti, and in this CodeRage session, we are going to explore FireDAC about performance and multi-DBMS support. So, FireDAC is a solid, robust, and powerful data access framework. It follows the dataset classes standard, what makes it closer to other frameworks like the old BDE and facilitates the migration from them. It is cross-platform, being able to be compiled for Win32 and 64-bit, macOS, iOS, and Android. It is cross-database, supporting all the main DBMSs in the market. It has a unified API with high performance and easy deployment. In a picture, we have all the FireDAC layers, and we can see that they are logical and clearly separated. We have non-visible components and visible component layers, the local data storage that supports XML, JSON, and binary format, the data adapter, and both layers can be debugged and monitored by its own mechanism, and the native driver layers that implement all the client API calls, and they are compiled and linked into your executable. That's what makes easy the deployment. So you don't need to send nothing beyond your executable and the DBMS client software that you want to use. About performance, FireDAC has great mechanisms and features to reduce the network traffic and the DBMS workload. We will see as an example the command batch feature, the array DML, synchronous commands, and batch move. About the portability, that means the multi DBMS supports, we're going to talk about data type unification, one of the most problems when dealing with multiple database management systems. We're going to talk about SQL dialect abstraction, macros, unified exceptions, and in my opinion, one of the greatest features FireDAC has, that is local SQL. Now, let's do some hands-on and see this in practice. So here we are with C++ Builder 10.1 Berlin up and running, and the first sample we are going to see is the command batches. Let's see this running first, and then we can see how this is created. Well, the focus here is to execute both SQL statements, two SQL statements, in the normal way first, and then with the batch command way. Well, here we have two tables, a customer table with 500,000 records and a product tables with 300,000 records, and both tables were fetched in about 2 seconds. With the batch command, the same tables and same number of records are fetched, but in less time. So how can FireDAC help us to achieve this improvement, to be faster? Let's see in code what happens here. Well, in the normal button, what we do here is just close the connection and clear the memory tables we are using to hold the data. And then we get the time, the initial time, open both queries, and get the time, the difference of the time spent. After that, we copy the data from the queries to the memory table in order to close the cursors and leave the queries, the database queries. In the batch way, it's a little bit different. The first difference we can see it's the fetch options property, that the auto close fetch options property that we set to false. The auto close options tells the FireDAC query to doesn't close itself. When I say close itself, I'm not telling about the active property, the query active property, but the internal cursor it has. When the FireDAC query gets the last record, it closes the internal cursor. But in this case, if we take a look at the data module we have here, in the normal way, we have both queries, the customer query and the product query separated, but in the batch we have both queries in a single command, in a single component. And when the FireDAC query gets the last customer records, it would close itself. But as we have another SQL statement, another data package record set, we need to tell the FD query to doesn't close itself. That's what we are doing here in this command. So we again clear the memory tables, get the time before it starts, open a single query with both SQL statements, and then get the time spent. After that, we copy the data from the FD query to the first memory table, and the second difference of the first method, the normal way to do, is this command. The first difference was the auto close options, and the second difference is the next record set. Next record set tells the query to go to the next SQL statement it has. In this case, the select of the products table. And after go to the next record set, we get its data from the same query and copy it to the other memory table. This way, we can go to the server a single time with one component and fetching all the data from the DBMS, reducing the network traffic, for example, and even some part of the database workload. So this way we can do the fetch faster. The second sample is about ArrayGML. Again, let's see this running first, and then we will see the code. Here we will do an insert of 2000 records in a table, first in the normal way, and then using the FireDAC ArrayGML technology. In the normal way, let's see how long it takes. In this case, we are doing an insert for each record, and on the ArrayGML we do a single insert. We can see how it is done. Take a look at the difference it has. It's a huge difference. And now let's see how FireDAC allows us to get this improvement. So the normal way, as we always do, is do a for from 1 to the amount of records we want to insert, that is in this spin edit component. And for each record we are setting the parameters and executing the query, and then go to the next, set the parameters, execute the query, and so on. After all, we get the time spent. This is the normal way to do. But with ArrayGML, it's a little different. We first tell the params property what is its array size, how many positions will have the params property. In this case, the 2000 we selected. Then in the for statement, we won't execute the query. We'll just assign the parameters values for each position of the parent array. And after all the params are set, then we execute the query with the same number of records that we set to the parameter array. This way, as I said, the FireDAC goes to the DBMS a single time and executes all the processes in a single way. That's why we have a huge difference in terms of time, execution time. So this is a nice feature you can use when you have a lot of data to a lot of SQL statements to execute in your DBMS. And with this you can have a huge improvement of performance. Another sample we are going to have is the asynchronous command. Asynchronous command, as it said, is a way to execute your SQL statements, your sentences in an asynchronous mode. One of the most hard things to deal with users is their patience. Not every time we can optimize, we can improve our SQL statements. There are some statements that in fact are slow to execute and the user don't have patience to wait, and well, you know how many problems we have in these scenarios. So in a normal way, when we execute a hard query, a slow query, you can see that the interface is locked, the clock isn't working, and just when the query finishes is that everything fine. If this is slow too much, your user will kill your software and whatever. So what we need to do is to let the UI responsive, let the user interact with the UI, or at least see that it is working. So how to do this? Executing the commands in async mode. So when you click on async mode and execute the query, we can see that the interface is working, the clock is working, and we have a progress bar to improve this. So another option of execution mode that allows the user to see your software is working. And the other option, that is cancel dialog, allows the user to cancel the operation it starts and then stop it. It's very good. For example, if you start a big report and you don't need to wait it to finishes, you just cancel it. Yes. So you maybe imagine how hard it is to do this. We need to create a thread or something else. No, you just need to open your query with a different execute mode. Yes, when the first option of the radio group is selected, we use the default execution mode, that is blocking, that is the UI will be blocked, will be locked until the query is in execution. And when we select the async mode, we just use this option in the execution mode of the resource option inside the FD query. Just it. And when we are using the cancel dialog, again, we just need to assign this value to the execution mode property. Just it. FireDAC takes care of everything else. And when you open a query with async mode, execution mode, it will run this query in a separate thread. But if this query is binded into a user interface component, for example the DB grid, you need to take care of this component usage. You can't let your user interfere on the query execution. So in the events of this query, you need to first, and before open, you need to clear the data set reference of this data source. So the user won't interact with the component that it's executing your SQL statement. And when it finishes its opening, you can of course point the dataset back to that query. All right, and in the after get records, we are only stopping the progress bar, setting it back to the normal style. So again, the query will be executed in a separate thread. So if you bind it to the user interface, you just have to take care of this binding, clearing the references before it is opened, and after it's opened, setting back the references. Just it, and changing the execution mode property. The other sample, that is batch move, is more related to your performance than the software performance. It's a way you can improve your productivity when you're dealing with data movement, when you need to get data from a source and save it into a target. Here we are doing a movement with the data from a table into a text file, from a text file into a table, and from both tables, one in SQL Server and the other in Interbase. So how this works: in the form, actions, and the buttons, we are just calling the methods in the data module. Get data, just open the queries, table to text, text to table, and table to table, do the data movement. Let's see these methods here in the data module. Well, as I said, get data, just do the close open in both queries, and the table to text and text to table uses the batch move component. Here we have a connection to SQL Server and another to Interbase, a SQL an FD query called SQL clients and SQL clients 1, and a batch move component. So two connections, a source, a target, and a component that does the magic. These components just need to be set on reader and writer. Who will be the reader and who will be the writer? And then you can set a dataset reader, a text reader, and a text writer or a dataset writer. You can read from a text file, you can write to a text file, in the same way you can read from a dataset and write to a dataset. And look, when we are saying that we write to a dataset and read to a dataset, you're not saying that you can use just FireDAC dataset. You can use any dataset compatible component that implements the methods FireDAC uses, that is append, insert, and post, and so on. So in each command we are defining who is the reader, who is the writer, and then executing the batch move. When the reader is a text file, you can call the guest format before the execution in order to ask for FireDAC detect the format inside that file. What is the delimiter, what is the date format, the number formats, and so on. Of course, you can define it by your own using the data properties in the reader or writer component. But if you call this method, you will be able to ask for FireDAC to detect it for you. I want to get its directory just to be sure the file doesn't exist anymore. I'll delete it and run this application. Open, I'll do a clear in this table, in the Interbase table. I will do an export operation using the table to text button. it will read all the files inside SQL Server, all the records inside SQL Server, and generate the text file. Let me change here in order to see this file being imported in the second option. Save it. In the text to table button, it is reading that text file and importing into the interbase server. And now let's clear interbase and do the table to table operation, importing the data from SQL Server into the interbase server. And they are equals. The two record sets are the same, but in different DBMSs. So every time you need to move big or any size of records from a source to a target, doesn't matter what source or target it is, any kind of DBMS, or if it's just a text file, a CSV file, and so on, you can use the FireDAC batch move components. It's really nice. So with these 4 samples, we finish the performance samples, and now we're going to start to talk about the multi-DBMS support. And one of the hardest things to deal with when working with multiple DBMSs is the data type unification, because even when we use the same SQL statement, the same data types in the SQL statement to create the tables in interbase and SQL Server, for example, in this case, the second field that is float in both statements will be recognized as different types inside Delphi. If we'd use the query without adding the fields, of course it will work, because FireDAC recreates the fields when you open the component, the FireDAC query, and everything works. But if you want to add the fields inside the data set to use its properties and be more productive, the fields will be added using the data types of the current database. In this case, it is interbase. So when we run the application with this field added, you can run on interbase, but it will have problem with SQL Server. If we change here the driver and add the fields, it will just invert the problem on interbase. It will work with SQL Server, but we will have problem with interbase. So what we can do in these cases is use the FireDAC data mapping rules. Here we can tell to the query or to the connection that every time it detects a data type inside the database, for example, if we get the single type, if it finds the single type in the database, it will add the field in the data set as a double precision. This, after do the settings, we can check that the field was single, and now if we add it again, it is a float field. And from now, if we run the application, you can see that in interbase and SQL Server it works smoothly, because FireDAC does the conversion for you in runtime. Now to the next sample, that is regarding SQL dialect abstraction. I created a powerful SQL editor to run queries in interbase and Firebird, and let's do a sample. For example, select all from the customers table. It works in interbase, it works in SQL Server, but what if I want to use some specific features of one of these databases? For example, I get the first 3 rows. In interbase, the syntax is pretty right, but in SQL Server it doesn't exist. So how to deal with it? to deal with the specific functions. FireDAC has macro functions and conditions. You can do a test inside your SQL to know in which driver you are current connected. And here, for example, if it is SQL Server, we do a top 5 rows and finishes our if. And here, if it is interbase, then we do rows 3 and finish our if. Now we can run the same query in both DBMSs and everything is fine. Beyond that, FireDAC has some functions that prevents you to know the name of these functions in all the databases. For example, if I get ID and name from customers and I want that the names came in uppercase and I don't know what is the function to upper the letters in interbase and SQL Server, but I know this function in FireDAC and this UCase. Now we can execute it both on interbase and SQL Server. That FireDAC will translate this function to the correspondent function inside these databases. Here in this link I left on the sample, you can get more functions that FireDAC knows and use in all the supported DBMSs. Another nice feature that FireDAC has to help us to deal with multiple database management systems. The other sample that we are going to see now is about macros. Do you ever needed to use parameters in object names, for example, to parameterize the table name? So now this is possible with macros. Here in this comment we have select all from some table where some field, some signal or operator, some value, and this works in runtime. Take a look. Here we have select all from customers where field ID equals 1 and we have the result. If I replace with the field name, the operator like, and let's get all those ones who finishes with 0, here they are. How does it works? Well, every time you write this kind of text inside a SQL statement that starts with an exclamation mark or the E, we can use this as a parameter, but it's called macro. Here the macro properties is where you can assign the values to these parameters. So we have the table, field, sign, and value macros, and in this button in the execute, what we do here is just to go through the value list rows that are the rows in this component and get the values of each row, putting it inside the macro value. Just it, and FireDAC will replace the macros with its values before sending the SQL statements to the database. The other sample we will take a look now is about unified exceptions. That is, exceptions are another hard thing to do when we are talking about multiple DBMSs, because each database management system has its own code and its own message, and sometimes we can use the text of that exceptions to try to unificate the control, but you know that this is not always possible. Sometimes the error messages of the systems are so different, and with FireDAC and its DB engine exception class, we can prevent this failure. We can be sure of what kind of exception is raised from the DBMS. For example, here, without check this, we are using the generic exception class and getting the message into the memo with Interbase and Firebird. But when we check this, we are using the FireDAC engine exception class, and with it we can be sure of what kind of exception is raised. And this other exception tells to the FireDAC that when an exception is raised, it can show its own dialog. This dialog is more user friendly and can help you in debugging time, because you have the error code, you have the kind of the exception of the error, the full message, the object in the server that raises that exception, the object in the application that raises that exception, and with this info you can help to debug. Let's take a look in the code, because all these buttons call the set data method, and in set data what we do here is just prepare the connection accordingly to the right target, the database type. If it's interbase, we set these parameters. If it's SQL Server, we set these other ones. And after that, if we checked the option to use the FireDAC engine exception, the try catch tests if the exception is of that kind, FireDAC DB engine exception. If it is, we have a property that tell us which kind of exception it is, and we can have UK violated, we have F key violated, we have record not found, we have so many kinds of exceptions that a DBMS can raise. And if you're using the FireDAC engine exception and we want to use the custom dialog, the FireDAC dialog, what we need to do is execute this component that was dropped in the form. This component you can customize only which provider we are using, if it's VCL or FireMonkey, and we can customize the caption of that dialog, only it, but this dialog is powerful and will help you in terms of debugging and investigating the errors. And in the else is the generic key try catch when we use the exception classes instead of the FireDAC ones. So another option, another feature to deal with multiple DBMSs inside FireDAC. And at last but not least, let's take a look at the local SQL feature. And I want to ask for your attention now, because it's a common situation we have here, and many times we use a hardest solution, but now with FireDAC it is so easier to do. The scenario here is that we have the sales records in SQL Server, and we have the customers records in Interbase, but we need to see them together, and that's what FireDAC does. It can use data from different sources, different databases, and run SQL statements in memory for these targets. How does it work? How can FireDAC do this? This works because of this component, the FireDAC local SQL. This component has mainly two properties: its connection and the datasets list. Here in the connection property, we will set the FireDAC connection that will be used by this component to create an in-memory database. This in-memory database uses the SQLite driver, you can notice that there's no physical file specified here because the database is created in memory using the SQLite driver. And with this set, what we need to do is to tell this component what are the data sets or the sources it will have. In this case, we are getting customers from Interbase and sales from SQL Server. We added these data sets inside these properties. You can see that is a simple list of data sets. Again, it's any kind of data set. You can use DBGO, EDO, IBX. You can use even BD or well, I don't recommend, but you can. And here we can give a name for each data set. In this case, we called the SQL customers data set as table customers, and the sales data set, that are these ones, we called it as table sales. And optionally, you can define a schema name for this local connection. After have these settings done, you can just use another SQL component, another SQL query component, FD query component, and in this component write a SQL statement on or over this in-memory database. Select all from local table sales that will be accessing the records provided by this component. Inner join local table dot customers, that are the records provided by these components. You are creating a SQL, a join of the records in memory. Again, this can be Interbase components, this can be DBGO components, this can be BD components, this can be a SQL query, this can be, for example, a FireDAC connection using the ODBC driver and connected, for example, in an Excel spreadsheet, and you can do a join SQL statement with your database query and your Excel spreadsheet. Really powerful, really interesting feature that FireDAC has, and as everything we saw here in FireDAC, it works on both VCL and FireMonkey. That means you can use local SQL even in your mobile applications. That's because I think local SQL is one of the greatest features that FireDAC has. So this way we finishes our session. Going now to the live Q&A. Here are my contact information. Please feel free to stay in touch, and thank you very much for your attention.